Good evening, all. Uh, I will start the lecture in 10 minutes as only one student, Sanjay, has joined. So I'll just wait for 10 minutes and then start. Okay. Good evening, everyone. Uh, Welcome to the week 5 of Biomass Conversion in Biorefinery. The course coordinator for this course is Professor Kaustubh Mohanty from the Department of Chemical Engineering, IIT Guwahati, and today I will be your I'm your PMRF TA, Arihant Ahuja from the Department of Paper Technology, IIT Roorkee, and I'm currently working under the Professor Vibhor Rastogi in the Department of Paper Technology, IIT Roorkee. So, before going towards the assignments, I will give you a brief about me. I have done my BTech from Bipin Tripathi Kumar Institute of Technology, Dwarhat, and did my MTech from IIT Roorkee, and currently doing PhD from the IIT Roorkee. And I'm receiving the Prime Minister Research Fellowship from 2021 to present for the project of paper-based value-added products. Today we will be discussing about the assignment 5 of 2021, 2022, and 2023. Before starting, I have removed some questions of assignment 5, 21, and 2022 as they were repeated in 2023. So those questions will be at the last. And I, you might have seen these questions earlier also, and you may also know the answers. But still, I will ask you the questions uh, this time, and feel free to answer in either by opening the mic or in the chat box. So the question is, what is the maximum moisture content of biomass that can be used in suspension fire units? So When we fire the biomass in a suspension fire unit, there is a particular amount of moisture that we require. We cannot go for a there is a limit for a moisture in which we cannot go higher. So, what do you think might be the maximum moisture content that we can use in a biomass? Any guesses? Anyone wants to make any guess? No one? Okay. So the correct answer for this is 55 to 65%. See, the maximum moisture content that we can use in biomass is 55 to 65%, but we generally use up to 50% moisture only. The 50% moisture results in a very optimum manner, and the maximum we can go is 55 to 65. So, biomass with higher moisture content may require additional drying process of processing cells to be suitable for use in suspension units. For example, if we have a biomass which has higher moisture content than 65%, then we may require some additional drying process. We need to do more drying and more processing just to remove the moisture. For example, if we have a biomass with like 70 to 80% moisture, then we will do some type of drying so that the moisture content in the biomass decreases below 65, or let's say between 55 to 65, or more preferably 50, nearly 50%, so that we can the process of further processing can be optimized. So the problem with high moisture is that when the moisture is very high, the combustion process becomes inefficient, which leads to incomplete combustion. So if moisture content in the biomass will be high, then the combustion is not very good. It will lead to incomplete combustion, which in turn will lead to lower heat output and increased emissions. Additionally, high moisture content also increases can also lead to slagging and falling issues in the combustion chamber. So the combustion chamber is made up of some type of metal or alloys which can get falling issues due to the high steam or high water content, because water can lead to corrosion also. So the high moisture content can lead to falling in the combustion chamber, hence it can also reduce the age of combustion chamber. Therefore, the further cycles if we do in the combustion chamber, it will reduce the efficiency of the unit also, and it turn will increase the maintenance cost. So if the moisture content is high, it will lead to incomplete combustion, lower heat output, increased emission, fouling of the combustion chamber, reducing the efficiency of the combustion chamber, and increasing the maintenance cost. Therefore, biomass with a moisture content higher than 50% is not typically recommended for suspension firing, but we can go for 55 to 65 at max. But 50% is typically recommended for combustion units. So now let's move on to the next question. Furfural resinization is defined as. So you might have remembered the furfural were some type of compounds which were formed um, uh, during the pre-treatment. So these were some compounds which were formed during the hydrolysis of hemicellulose. In week 4 we have discussed this thing that when we do the hydrolysis of hemicellulose, we get soluble we get something which is known as soluble hemicellulose, which are type of sugars. These are particular sugars, but we sometimes also get some unwanted compounds such as furfurals. So furfural, the question is about furfurals. So furfural resinification is defined as: it is a reaction in which furfural reacts with itself. It is a reaction in which furfural reacts with xylose. It is a reaction in which furfural reacts with one of the intermediate of xylose to furfural. So, what do you think might be the furfural resinification? Any guess? Okay, so it is a reaction in which furfural reacts with itself. So furfuryls are some kind of unwanted compounds formed during the hydrolysis of hemicellulose, and these furfuryls reacts with itself to form something which is which is a type of resin. So I will explain this resin and furfuryls in the next slide. So, resinification process is the process by which furfuryls, a chemical derived from lignin biomass, undergoes polymerization to form furfuryl-based resin. So, it is a type of cyclic compound, and it reacts with itself, and it forms a very dense and sticky substance. It forms a very sticky substance when it reacts with itself, and this sticky substance is known as resin. You might have heard this term somewhere, that we have used resin for adhesive in any other application. So furfuryls react with itself by heat and temperature and time, and it forms something which is known as resin. This formation of resin is known as resinification, and when furfuryls form resin, it is known as furfuryl resinification. And this furfural is so now we have understand that furfural is a cyclic aldehyde that can go undergo self condensation in the presence of acid catalyst to form furfural resins. These resins have a wide variety of application, including use of adhesive, coating, and thermosetting materials. So we can use this furfural resin for some other applications, such as adhesive, coating, and thermosetting material. So whenever we get furfuryls during the hydrolysis of hemicellulose, we can just extract the furfuryls and do the polymerization to form the resin, and use it for wide variety of applications such as adhesive, coatings, and thermosetting materials. The properties of the furfural resin can be controlled by adjusting the reaction conditions such as amount of catalyst, temperature, and time. So the higher the temperature and higher the time we will give it, the harder the resin will get. So the reaction takes place in the presence of high temperature, and it also increases with time. So this is a particular furfural, and it reacts with itself and form a type of resin. You see, it has now connected by itself, and this that's why it is also known as polymerization of furfuryls to form a resin, which is particularly sticky in nature, can be used in adhesives and other coating applications also. So the next question is, the main drawback of Quaker oat batch process is. So do you remember what is Quaker oat batch process from the lecture? No one? Okay. So Quaker, I will explain this in the next slide. So first we will go to the main question. So the question was the drawbacks of Quaker oat process. Is it low yield, low efficient production, or substantial steam requirement? So the answer of it is very low yield and substantial steam production. In this process, there are this is low effluent production is not a disadvantage. It is an advantage. That's why it's not the right answer. And right answer is low yield and substantial steam requirement. But what is this process? What is Quaker process? So, Quaker process is a pre-treatment to convert biomass into some valuable products. And in this, biomass is treated with an acid such as aqueous sulfuric acid or phosphoric acid. So we use sulfuric acid or phosphoric acid and also steam. And we treat the biomass with this acid and steam at nearly 153 degrees Celsius. And it is also known as hydrolysis step, and this hydrolysis step of biomass converts it into pentosan and pentosis. So in this way, biomass can be converted into pentosis. The whole process of any of the treatment, such as acid hydrolysis or alkali pretreatment or organosol pulping or uh, enzymatic hydrolysis or this Quaker process, everything has to do only one thing, that convert biomass, which is made up of cellulose or hemicellulose, and convert it into its monomer or dimers into. So the uh, main thing is to convert polymer into monomers. So you have read many of the process, but the main aim of all the process is to convert to the polymer into monomer. Just that, so that we can use this for fermentation and then produce biofuels. So Quaker Oats process is also a similar process, and in this particular reaction process, we use acid in the presence of steam. So we use acids and steam so that we can get pentosis from the biomass. So these pentoses can be converted into furfural, or subsequent stage in furfural can be recovered by stream stripping from solution. And but the main problem with this process is it has a very low yield of 50%. It has a very low yield, and it also requires very much high steam for the reaction. And steam is a to produce steam is a very costly process in industry, and it also has a very high effluent production. That's why the because we use axis in it. So that's why its major disadvantage is that substantial requirement of steam and very low yield, because the acids present sometimes degrade the biomass also. These acids can degrade the biomass also. So when it degrades the biomass, then we get very low yield. So this yield is also very low. Now let's move on to the assignment 5 of 2022. Most of the assignment 5 of 2021 were repeated in 2023. So those questions I will be discussing at the last. So the process by which wood absorbs moisture from humid air is known as. So wood has hydroxyl bonds. It is hygroscopic in nature, and it can, does it is it attracts moisture from the environment very rapidly. But what is the process in which wood attracts water? Is it adsorption, absorption, humidification, or both? Any idea? Any guess that what phenomena do we the wood uses to absorb water? Okay, so the answer is both A and B. Wood is very hygroscopic in nature, and that's why the moisture from the air can come onto the surface of the wood. And after the water comes on the surface of the wood, it goes inside and gets absorbed. So the water coming in physical contact with wood is known as adsorption, and when it goes inside the wood, it is known as absorption. So in both ways, wood absorbs water from the humid air. So first of all, we will see the word absorption. It refers to the process of one substance being taken up or dissolved by another substance. So if a substance take a substance inside it and forms a one component type thing, then it is known as absorption. So when there is a absorption, it forms a homogeneous mixture. So the absorbed substance becomes a part of the absorbing substance, often resulting in homogeneous mixture. In absorption, a mixture is becomes mostly homogeneous. For example, sponge absorbs water. The water is taken up and becomes a part of a sponge. On the other hand, the adsorption is a process of a substance sticking to the surface. So, in adsorption, water molecules will stick to the surface of other substances without necessarily being taken into the substance itself. For example, charcoal is used to filter impurities from water. The impurities are adsorbed onto the surface of charcoal. So the impurities present in the water will go on this charcoal surface. They will not go inside but onto the surface. So this is adsorption. So if we look at this particular example, if we have a surface here, and if we're talking about the adsorption, the molecules or water molecules will come to the surface of the will come to the surface. It will not go inside. It will not go inside in case of adsorption. But in case of absorption, the water molecules will penetrate the surface and go inside the structure. It will go inside. So in this case is known as absorption. So when there is a humid air present in the environment, the wood will first adsorb the molecules from the air, and water molecules when come to the surface will go inside the wood. So in this case, wood uses both adsorption and absorption both. So the second question, the relation between flame temperature and moisture content of the woody biomass is directly proportional, indirectly proportional, independent of each other. So the question revolves around that if I have a biomass, if particularly woody biomass, and it has high moisture in it. If it has high moisture in it, then what will be the requirement of flame temperature? If it is high biomass, will we require higher flame temperature? Then the answer will be directly proportional. If it is inversely proportional, means that higher the moisture, lower the flame, then this will be the answer. Or there is no relation between them. So the answer to is that it is directly proportional. How is it directly proportional? So flame temperature is directly related to the amount of heat necessary to evaporate the moisture content in the wood. So higher the moisture present, higher will be the amount of heat required to evaporate the moisture. Therefore, higher will be the flame temperature. And similarly, if the amount of moisture is lower, the lower amount of energy will be needed to remove the water and higher the boiler efficiency. So that's why to increase the boiler efficiency, we need wood with low moisture content. And also we have seen in the first question of this slide also that the moisture content of 50% is preferred, 50 to 55 to 65%, and not above that, because it will result in lower boiler efficiency. So as the moisture content of woody biomass increases, the amount of energy to require to vaporize the moisture will also increase. That's why the answer is directly proportional. So now let's move on to the next question. In the commercial steam explosion of biomass, the typical pressure of the steam is, so there's a process in which biomass is exploded by only a steam and not without any chemicals. So that process is known as steam explosion. We do not use any kind of acids, we do not use any kind of alkali or organosolves. We only use steam. So what kind of pressure it uses? 7 to 10 MPa, less than 7, 10 to 15, or more than 15 MPa. Anyone wants to make any guess about this? Anyone? You might know the answer also, and don't think that the answer might be wrong or right. You can make a guess also. No one? Okay. So the answer for this is less than 7 MPa. Particularly, we require around 3 megapascal of pressure in case of steam explosion. So answer is 7 MPa. So the pressure, we use 1 to 3 megapascal, 3.5, we use 1 to 3.5 megapascal of pressure for the steam explosion, and this amount of pressure is sufficient to cause the biomass to undergo rapid and intense pressure release. And this, if the steam goes inside the biomass with very high pressure, it will burst this biomass and disrupt the cell structure. So the cell will also be disrupted, and the fibers will inside it will also get disrupted due to this high pressure. So 3.5 megapascal pressure is sufficient to disrupt the whole structure of biomass, and this will lead to fibrillation of biomass. So every individual fibers will get open. It will form a very open structure. So this open structure will lead to an increase in the accessibility of cellulose to enzyme or chemicals for further processing. So before we do any kind of acid hydrolysis or organosol process or any other thing, we can also do steam explosion, because this steam explosion can also reduce the amount of chemicals required in the next step, because we have already opened up the fibers, and thus the amount of acid required to go inside them will be less required. So steam explosion is also sometimes done prior to the any kind of acid treatment or alkali treatment or any other thing. So the fourth question of this is, hydropulpers are generally considered as, so dry shredder, combination of dry and wet shredder, or free swing hammers. So if we go towards the word, it has a word hydro in it. So hydro means water. You can guess that hydro means water, and therefore the answer should be wet shredder. So the answer for this is wet shredder. But before going it, what is hydropulper? So hydropulper is a machine in which we can give uh, some kind of recycled materials also, such as recycled cardboard and some newspapers. We can put these recycled thing. We can use this waste biomass into this hydropulper, and there is a mechanical mechanism which rotates in it, and these blades cut the fibers and fibrillate the newspaper into the fibers. Plus there is water also in it. So hydropulper works on two mechanisms. First is uh, the cutting action by the blades, and second is the force created by the water. So in the water and mechanical forces, both combine very synergistically just to make fibers out of the cardboard or newspaper or any other waste biomass. So in this way, we can also use waste biomass. We can use the waste biomass to create fibers, and then we can use those fibers to treat them and then produce some kind of products by fermenting them. So hydropulpers are considered as wet shredder because they use water to soften and break the biomass material into soft pieces. Water acts as a lubricant, allowing the material to be shredded or pulped by the rotating blades or hammers inside the pulper. The resulting slurry can also be further processed for various applications such as biofuel or bioproducts. So in now I hope that you have understood what is hydropulper, the mechanism of it, and why the use of water in it is water is used in the hydropulper. That's why it's also known as wet process. So the next question is, which type of feedstock can be used for supercritical water gasification? Is it dry feedstock, wet feedstock, both A and B, or none of the above? So the answer for this wet feedstock, and you can easily guess it because the name, if you go towards the name, supercritical water gasification. So it has a word water in it. So it only uses wet feedstock so that to continue the process. But what is the supercritical water gasification process? Supercritical gasification is nothing but in this process we take the biomasses, any type of biomass, either it is wood or vegetation or any type of husk or grasses. We can take any type of biomass and give it some conditions. Those conditions are known as supercritical conditions, and that is temperature above 374 degrees Celsius. We have to give a temperature of 374 degrees Celsius and a pressure of 22.1 megapascal. So these are the supercritical temperature and pressure of water to generate a state in which water exists neither in liquid or vaporized phase. So this is known as supercritical water gasification process. In this process, these lignobiomasses converts into some useful gases such as hydrogen, carbon monoxide, carbon dioxide, and methane. And this we can use as fuel for further uses. So we can use the main advantage of this process is that we can use any type of lignocellulosic biomass, any type of waste biomass, and just by giving pressure and temperature, high pressure and high temperature, we can convert it into useful gases. So generally, this process can take both dry and wet feedstock. Supercritical water gasification can take both type of feedstock, but wet feedstocks are preferred as they are easy to handle and of high energy density than dry feedstocks. So, supercritical water gasification is a process that uses water at very high temperature and pressure. This is also called supercritical condition to convert biomass into gaseous fuels. In this process, biomass is converted with water and fed into a reactor vessel where it is heated above its critical point. Heated above its critical point, that is 374 degrees Celsius and 22 megapascal of pressure, more than 22 and more than 374 degrees Celsius. So if we give it a very high temperature and high pressure, we can convert any kind of lignocellulosic biomass into useful gases. So what is this supercritical condition? So supercritical condition is a state in which water exists in a state that is neither liquid nor gas, but instead it has a property of both. It is so at this high pressure and temperature, it is not in neither in liquid state nor in gas state, but it will show the property of both, and that's why it is called supercritical condition. Under these conditions, the biomass breaks down into gas composed primarily of hydrogen, carbon dioxide, and methane, and the resulting gas can be used as a fuel for power generation or as a feedstock for production of other chemicals. So in this way, we can utilize the waste biomasses to produce some products which has a very high economical value. Supercritical water gasification has several advantages over other biomass to fuel, such as it can handle a wide range of feedstock. As we have already discussed that it can handle any type of feedstock such as woody biomass, non-woody biomass, any type of straw, grasses, anything. It can we can use a very wide range of feedstocks. Also, it has a very high conversion rate and very low emissions. And all the gases which we get, hydrogen, carbon monoxide, and methane, can be used either for fuel or for some other, or we can use these gases to produce some other chemicals also. So it has a very much high advantages over other uh, processes. So now let's move on to the sixth question. What are the different products produced from the ultra rapid pyrolysis? So the option for it is bio oil, chemicals and gas, charcoal, and the next option is chemicals and gases. So first of all, what is pyrolysis? Pyrolysis is nothing but a process in which we burn some we heat some biomasses in absence of oxygen or in absence of air and at high pressure and high temperature. Then it is known as pyrolysis. And what is ultra rapid pyrolysis? Ultra rapid pyrolysis means that we use very high heating rate. We use this very high heating rate, and we also use high temperatures. So this high temperature and high heating rate in pyrolysis is known as ultra rapid pyrolysis. The main objective to do high to give higher temperature is so that we can get higher amount of bio oil. We need bio. We actually get very much amount of chemicals, but the main objective is to get bio oils. So, but we also get two other products, and these are bio oil, gases, and some amount of char. The NPTEL answer shows that we get chemicals and gases from the ultra rapid pyrolysis, but the correct answer to this is bio oils, gases, and some amount of char. We get char, but very in very small quantity. So first we will go towards what is ultra fast pyrolysis, and then we will talk about the comparison of ultra fast pyrolysis to conventional and or normal pyrolysis. So ultra fast or flash pyrolysis is an extremely rapid thermal decomposition pyrolysis with a high heating rate. So the main thing which ultra fast pyrolysis has is high heating rate. And this is a chart which shows that high heating rate and high temperature what kind of oils it lead to. So this one example which I have shown here is a type of ultra fast pyrolysis. So the yellow part in this pie diagram is oil, which is also known as bio oil. So we get bio oils and some amount of gases and very less amount of char. And when we go for a conventional process, we get oils but in very less quantity. And we but the thing is when we get very high amount of char. So the main thing which we are getting by increasing the higher heating rate is that increased content of bio oils. We get very high amount of bio oils and very less amount of char. So we have reduced the amount of char and increased the amount of bio oils just by increasing the higher heating rate. So that's why it is known as ultra fast pyrolysis. It is also a very fast process also. So here is a comparison of conventional or slow pyrolysis, fast pyrolysis, and ultra fast or flash pyrolysis. So the heating rate in slow pyrolysis is 10 degrees Celsius per second. So per second, the temperature will rise by 10 degrees Celsius. But in ultra fast or flash pyrolysis, the heating rate is very high. It is more than 500 degrees Celsius per second. It is a very high heating rate, and we also achieve very high temperatures such as 700 to 1000 degrees Celsius. The temperature here is in degrees Celsius. Whereas the slow pyrolysis, we only get around 400. We take around 400 to 500 degrees Celsius, and the residence time is also short. In case of ultra fast, it is less than zero point 0.5 seconds. The major products which we get during the pyrolysis are gases, char, bio oil, these three things. But in ultra fast pyrolysis, we get very high amount of bio oil, and we also get char, but in very low amount that we often neglect it. But in conventional or slow processes, we get char and gases very much high and bio oil in very less quantity. So the if we need bio oils in very high amount, we can offer ultra fast or flash pyrolysis. And how to what is the difference between ultra fast and conventional pyrolysis? There is only one difference: high heating rate and higher temperature. So now let's move on to the seventh question. The approximate yield of bio oil from the fast pyrolysis process is, what is the amount, approximate yield which we get? So we have seen that ultra fast produces a very high amount of oil and than the conventional, and fast is in the between. So the answer for this is 60 to 75. So we get 60 to 75% of bio oils from the fast processes. So okay, what is fast pyrolysis? It is a process that quickly heats the biomass to high temperature in absence of oxygen to produce bio oil, gases, and char. The yield of bio oil depends on various factors such as type of biomass, temperature, and residence time of the pyrolysis process. And typically, the yield is between 60 to 75% of bio oil. This is because fast pyrolysis is designed to maximize the yield of bio as a primary product. However, the yield can depend on uh, very different, very conditions such as the time, temperature, because there is a very broad range in temperature also. So that's why the yield is has a very broad range, that is 60 to 75%. Now let's move on to the eighth question. Which of the following pyrolysis reactor can process biomass having large particle size? So till now we have seen what is pyrolysis. That pyrolysis is a process in which we heat the biomass. We heat the biomass and in the absence of oxygen. But what kind of reactor will we require if we have a very high, larger particle size? So the answer to this is vacuum pyrolysis reactor. So the advantage of vacuum pyrolysis reactor is that first of all, if we get very clean oil, if there is a vacuum, if we create a vacuum inside the pyrolysis chamber, then we will get a very clean bio oil without any contamination. So the quality of bio oil is superior in vacuum pyrolysis, and there is also one more advantage that we can use some larger particle size, such as 3 to 5 centimeter. We can also go for 3 to 5 centimeter of particles in the pyrolysis process, and no carrier gas is required, and also lower temp. We can also conduct the pyrolysis in lower temperature, just because by applying a vacuum in it, we can go for lower temperatures also. But it has some disadvantages, such as it has a slow process. It The residence time is also high. Residence times mean the contact of heat and with the biomass. So that time is also high. That's why it is a slow process. And the vacuum it in vacuum pyrolysis we are applying a vacuum, and we can also give particle size of 3 to 5 centimeter. So one more disadvantage is that we require a very large scale equipment for this. We cannot do it in a small equipment. We need a large scale equipment. And as the equipment is very large, so the heat and mass transfer rate are poor, because the temperature and mass transfer rate can be different at different positions just due to the high amount of due to the large size of the container. Therefore, it also has a disadvantage of poor heat and mass transfer rate. Also, it generates water also when compared to other processes. So the apart from the advantage of using 3 to 5 centimeter larger particles, it also has some types of disadvantages. So now let's move on to the ninth question. The homogeneity of pre-consumer food waste is dash compared to the post-consumer food waste. So first of all, what is pre-consumer food waste and post-consumer food waste? So pre-consumer food waste is nothing but it is a waste which we have not used. We as a consumer have not used, and it becomes waste before consuming. And post-consumer mixed waste means we have consumed it, and somehow when we dump it into the yard, we mix it with very different things such as packaging also. So pre-consumer food waste will be of homogeneous type, and post-consumer will be heterogeneous, because we uh, mix things after the consuming it. So the question was, the homogeneity of pre-consumer food waste is. So homogeneity is higher for pre-consumer food waste. So if we go for a small example, um, pre-consumer food waste typically comes from a single source, such as restaurant or food processing facility, and it is often sorted and separated before disposal. So this is a type of food waste, pre-consumer food waste, and it has high homogeneity because it also goes for sorting method procedure. Whereas there is a method in post-consumer food waste. It comes from a very vast variety of sources, such as household, commercial buildings, public spaces, and it contains very much impurities. It will have food waste, but it may have paper, plastic, or other materials such as packaging. So post-consumer food waste is not homogeneous, but it is heterogeneous. Therefore, the homogeneity of pre-consumer food waste will be higher than post-consumer food waste, and that's why if we want to do some, if we want to create some fuel or other useful products out of the food waste, we will prefer pre-consumer food waste because they are homogeneous and therefore the yield will be high for these products. But if we are using post-consumer food waste, we may need some kind of sorting or cleaning before going towards the chemical reactions or other doing further processing. The main product obtained from the fermentation process is, so by now we have seen that whatever we are doing, we are just uh, breaking the polymers such as cellulose and hemicellulose into smaller sugars, which are monomers. So why we are breaking it? So that we can do fermentation of the sugars. So what this fermentation will lead to? So we can obtain bioethanol and or carbon dioxides. So the main process for this is that we take any type of biomass and take the cellulose or hemicellulose of it and then convert it into sugars, which we will do the fermentation and obtain bioethanol. And this bioethanol will act as a fuel. So the main product of fermentation is bioethanol, and the secondary product is carbon dioxide. It also produces many other products which are in very minor quantity. So one of the most common products obtained from the fermentation of is bioethanol, which is produced by anaerobic fermentation of sugars present in the biomass. Other fermentation products may include biogases such as methane, carbon dioxides, and it may produce some types of organic acids, hydrogen gas, and various gases depending upon the feedstock and processing conditions. But the major thing which we get is why we are doing all this thing, why we are taking the biomass and treating it with acid, alkali, organosol. We are just breaking those complex polymers into smaller sugars or monomers just so that we can ferment those products and produce bioethanol. So the main objective of all the pre-processing or the other treatments was to produce bioethanols out of the biomasses. So you all might have done the assignment 5 of 2023, and the deadline for it was 2 days ago only, and you may also have received the answers, what are the correct answer for those. And now I will discuss those questions answers and the reasoning behind it so that you can get your concept very clear. So the first question of this year of assignment 5 was the common type of dry shredder used for reducing the size of biomass is. So what is a dry shredder so that we can reduce the size of biomass? Hydropulper, horizontal shot mill, vertical shot mill, or both PNC. Now, from the previous questions, we have seen that hydropulper is a wet process, and also we can guess from the name hydro that it is not a dry shredder. So the answer for it is both B and C: horizontal shaft hammer mill and vertical shaft hammer mill. So you have all seen the mechanism of the hydropulpers, that it has a cutting action by the blades, and it also uses the centrifugal forces of water inside it, and thus with the help of water and mechanical forces, the we can disintegrate the fibers in the hydropulper. So it is a wet shredder. We reduce the size by a wet process. So hydropulper is a wet shredder, it is not a dry shredder. But hammer mills are dry shredder. Hammer mills are known as dry shredder. So these are of two types. One is vertical and second is horizontal. So first of all, before going towards the vertical type and horizontal type, what are hammer mills? So hammer mills are mostly impact grinders with swinging or stationary steel parts forcing ingredients against a circular screen or solid serrated section designated at a striking plate. So it is nothing but it is a type of grinder in which there are steel bars and they swing, and then they reduce the size of biomass with a force. In this, the material is held in the grinding chamber. So there is a chamber which is known as grinding chamber. We will put a material in it, and the hammer mills will be used until the size has been reduced. And in this, it is a type of mechanical process. There is no water in it. It is purely dry process. But this high mechanical activity will lead to increase in temperature, and therefore heat is imparted to the material due to the work of grinding, and it is related to the time it is held within the chamber. So you might have seen some type of milling, ball milling also, that in a ball mill there is a ball and it hits the surface on both the sides, and it hits at a very high frequency, and with time it generates a amount of heat. So therefore heat is also generated in this chamber, in this process. So it is a type of impact grinding. We are impacting the biomass with a hammer, so it is a type of impact grinding also. So impact, it is the most efficient with dry and low fat ingredient, although many other materials may be reduced in size by proper screen selection and regulated intake. So, but what is this? There are two types of hammer mills. First is horizontal type, and second is vertical type. So, in a horizontal shaft hammer mill, it has a horizontal drum-like cylinder. So, it has a horizontal cylinder with several rows of free swinging hammers. So, it has a horizontal drum, and there are rows of free swinging hammers, and it is attached to a shaft. So the shaft will rotate, and the hammers will then impact the biomass inside it. So biomass material is fed to the mill from the top. We will get the biomass from the top, and it is pulverized. Pulverized means in if I explain this in layman terms, it just means reduction of size. So the biomass is fed into the mill from the top, and it is pulverized by the repeated impact by the hammers against the material. The ground material is then discharged from the bottom of the mill, and we get the grounded or reduced size particles from the bottom of the mill. And in case of vertical hammer, it has a vertical rotor. The rotor is vertical in this. You can see it here, and it has several rows of hinge of fixed hammer attached to it. And in this also the biomass is fed from the top into the mill, and then is pulverized by the impact of the hammer against the material. And in this case also the ground material we get from the bottom. So the mechanism of both are same, just the difference is that one is a vertical process and other is a horizontal. But the main thing is that hammer mill is a type of impact grinding or wet grinding. It is not a dry grinding. There is no involvement of water in it. So the second question of this year was the density and the moisture content of bellied straw is in the range of. So first of all, what is bellied straw? So, baled straw. So, what is bale? Bale is nothing but a compressed form of biomass. See, we have biomass or cellulose. Whenever we see the cellulose and biomass, they are very fluffy and they takes up very much high space. So we just will compress it and to blocks of biomass, and these high compressed is known as bale, B-A-L-E or B-A-L-E-S, bales. So the and if we are using straw as a biomass, then this will be known as baled straw. So the density in moisture content of baled straw is in the range of. So the correct answer for this is 70 to 90 kg meters cube and 10 to 15 weight percent. So this is what a baled straw looks like. So it is a straw material, and we have just compressed it so that it can take less space. So baled straw is a straw that has been harvested and compressed into bales for storage and transport. We only use this. We only convert this, compress this, so that the transport and storage is optimum, and the transportation is also very easier. And what is a straw? Straw in an agriculture is an agriculture byproduct consisting of dry stalk of cereal plant such as wheat, rice, and barley. Um, it You might also have heard that there's a pollution near Delhi NCR due to subtle burning of straws. So those straws can also are also biomasses, and those biomasses can also be used to convert fuels and other bioproducts. So those are the straws which we see in news about the subtle burning in Delhi NCR and causes pollution in Delhi NCR. So now you have understood that what is a straw. Straw is an agriculture byproduct consisting of it can be made up of wheat, rice, barley, or oats, and that's it. Hence its names come wheat straw, rice straw, or other barley straw and oats. Baled straw is commonly used for animal feed, bedding, and mulch, and it can also be used for as a feedstock for bioenergy production. So now let's move on to the third question. The increase in moisture content of biomass. So, how does the content of biomass affect the boiler efficiency? How does the moisture content in a biomass affect the boiler efficiency? So in the previous slide also that we have seen that if there is a high moisture content, we need to reduce the moisture by some pre-drying. We need to do pre-drying if we have a moisture content more than 65%. If the moisture is more than 65%. So why we are doing the pre-drying? So that the boiler efficiency is not reduced. So that's why the increase in moisture content will decrease the boiler efficiency. So the increase in moisture content of biomass decreases the boiler efficiency, and this is because the energy required to evaporate the excess moisture present in the fuel reduces the available energy of combustion, leading to decrease in boiler efficiency. Also, higher the moisture content, will be the falling of the boiler. So hence, the boiler efficiency will get reduced. The moisture content in the biomass should be controlled to obtain the optimal combustion and maximum the energy output. So how can we control the moisture? By doing pre-drying or any other type of treatments just to reduce the moisture to attain moisture less than 75, so less than 65%. And if the optimal conditions will be are those we will get optimal combustion when the moisture content will be near to 50%. So now let's move on to the fourth question. The temperature maintained in the pyrolysis zone of a gasifier is. So now you have seen that what is the pyrolysis. Pyrolysis is a technique in which we burn the a substance. In our case, we will burn the biomass in the absence of oxygen, and we can also apply vacuum to it. So what type of temperature do we require? By now you have seen also seen there are three types of pyrolysis: low, conventional, fast, and ultra fast. So therefore the answer for this is 315 to 1000 degrees Celsius, because uh, different temperature are required for different pyrolysis technique. If it is a conventional pyrolysis method, then we may require lower temperature. If it is a fast pyrolysis method, then we need mid temperature, and if it is ultra fast pyrolysis temperature, then we may need higher temperatures by providing particular heating rates. So, what happens in this process is that the dried feed enters the pyrolytic zone in which temperature ranges by 315 to 1000 degrees centigrade. And there's one thing also, that different feedstock may require different temperature. Temperature, the, we may require the temperature according to the process also, and sometimes the temperature also varies with feedstocks. So different feedstocks may require different temperatures. The pyrolysis process typically involves heating the biomass between 300 to 800 in the absence of oxygen to produce biochar, syngas, bio-oil. And the temperature range of 315 to 1000 in the pyrolysis zone of a gasifier is suitable for the pyrolysis process. The lower end of the temperature range, such as 315, is closer to the lower limit of pyrolysis temperature, and it could be used for low temperature pyrolysis process such as conventional pyrolysis. And higher end of temperature range such as 800 to 1000 may be required for high temperature pyrolysis process that may need certain types of feedstock or applications, or for ultra fast pyrolysis also. As we have seen this table also earlier, that conventional pyrolysis requires medium temperature of about 400 to 500, fast pyrolysis requires temperature of 400 to 650, and ultra fast requires 700 to 1000. Also, the temperature may vary dependent upon the type of biomass. So that's why we use a very wide range of temperatures, such as 315 to 1000 degrees Celsius for pyrolysis method. So the correct answer was 315 to 1000 degree Celsius. In the updraft gasifier, the gasifying agent enters from. So I will explain this in the next slide. So the gasifying agent from in a updraft gasifier comes from the bottom. So the gasifying agent comes from the bottom and fuels enter from the top. Fuel here means biomass. I'll explain this in the next slide with a diagram. It might seem complicated here. So in it is a type of updraft gasifier. In this, we give our biomass from the top, and we give our steam plus air from here, which is also known as gas, and it will be heated from the bottom. This gas will go from bottom to top, and biomass interact with biomass in the opposite direction. And this is done so that the gases which goes into contact with the biomass are heated, so that the heated gas comes in contact with biomass and results in high yield. So in an updraft gasifier, it is a process to convert biomass into a gas called producer gas and syngas. So what we are producing, we want to produce a fuel which is known as syngas or producer gas. And in this gasifier, the gasifying agent such as air enters from the bottom. So So air will be entered from the bottom of the gasifier and flows upward. This air will flow upward through the biomass fuel bed, and this is known as biomass fuel bed. The air will enter from the bottom, heats up, and go through the biomass fuel bed. As the air passes through the fuel bed, it reacts with the biomass. Here, the reaction will happen between biomass and air. In this section, there will be a reaction between the biomass and air, and it will react with the biomass at very high temperatures, such as 800 degrees Celsius to 1000 degrees Celsius. And in this way, the biomass will be converted into gas or fuels. So there is a reason that in updraft, that why we are using the gas from the bottom, that why the air is entering from the bottom, why not from the top. So the reason for the gasifying agent entering from the bottom is to ensure that the biomass is exposed to higher temperature as it is gasified. So when the air will goes from the bottom, it will get heated up with, and it will attain a high temperature. And when the gas will interact with the biomass will be exposed to high temperature. As the gasifying agent move upward through the biomass bed, it becomes heated and helps to dry and preheat the biomass. It will also help to dry and preheat the biomass if there is any kind of moisture in it, because moisture also reduces the efficiency. So the heated gas will also remove the moisture from the biomass. And after this, the biomass undergo the pyrolysis process, where it is broken down into volatile gas such as charcoal, and we get the charcoal from upward direction. So that's why the gas is entering from the bottom. It goes up, and the biomass comes from the top, and it dries the biomass, and this biomass is then converted into some fuels which we get after the pyrolysis process. And there is a the reason that why fuel or bio that why biomass enters from the top. So biomass enters from the top of the gasifier and flows downward through the gasification zone. This allows the biomass to be preheated. There's the same process that biomass needs to be preheated and dried by the hot gas produced during the pyrolysis. The downward flow of the fuel also helps to ensure that the biomass is exposed to higher temperature for a longer period of time. So if the biomass will come from the top and will come from the bottom, the contact time between the biomass and the gases higher temperature will be more. So therefore, in an updraft gasifier, biomass is uh, sent from top, and the gases or air is sent from the bottom. Now let's move on to the next question. The retention time of vacuum pyrolysis is. So we have seen what is a vacuum pyrolysis. Vacuum pyrolysis is nothing that we just need to heat the biomass in the absence of pressure. We need to do it in the, with vacuum and with the absence of air. And what were the advantages of vacuum pyrolysis? The main advantage was that it can use large amount of it can use big biomasses also, which ranges from 3 centimeter to 5 centimeter. So if we have bigger particles, we can use vacuum pyrolysis. But what is the retention time during this process? The retention time during this process is 2 to 30 seconds. So retention time, what is retention time? What do you mean by retention time? So retention time refers to the amount of time that the biomass is exposed to high temperature and low pressure inside. So the amount of time it is exposed to temperature, is known as retention time. Retention time in a vacuum pyrolysis can vary depending on several factors such as type, size of the feedstock, operating condition, and desired end products. So, if the feedstock is larger, we may, if the size of the feedstock is higher, we may need higher retention time. If the feedstock is lower in size, then we can also go for lower retention time. Therefore, was a very broad range of retention time, 2 to 30 minutes. It is a very broad range because it is dependent upon the type and size of feedstock. It also retention time also depends upon the temperature. If we are using conventional pyrolysis, then we may need higher time retention time. If we are using ultra fast pyrolysis, we may require lower retention time. So that's why the variation of the retention time is higher. So the broad range of retention time, 2 to 30 seconds for a vacuum pyrolysis, is because different types of feedstock may require different retention time to achieve desired product yield, and it also depends upon the processing. So now let's move on to the seventh question. In the pyrolysis process, the mechanical mixing of biomass and sand is done in which type of reactor? So there are four different types of reactor here: fluidized bed, ablative reactor, rotating cone reactor, and fixed bed batch reactor. So in this, which one uses the mixing of biomass with sand? So the answer for this is rotating cone reactor. But before going to the answer, what are these four types of reactors? What is the difference between them? So in the fixed bed batch reactor, biomass is loaded into a reactor vessel and heated under the inert gas atmosphere. So in this, we just load the biomass. We just load the vessel with the biomass under inert gas. We use very inert gases in this process, and the heat causes the biomass to undergo pyrolysis, and the vapor produced are collected and condensed. In the fixed bed, reactor can handle wide range of feedstock and has relatively low operating cost, but has a slower erection rate and requires more frequent cleaning and maintenance. So the cost is very low, but the reaction rate is also low. And if the reaction rate is low, it will take higher amount of time. So this is the advantage and disadvantage of fixed bed batch reactor. And what is a fluidized batch reactor? In this, the biomass particles are suspended in an upward flow of gas, typically an inert gas or steam. The gas flow is strong enough to keep the biomass particles in motion and prevent them from settling. So, in this, the air is passed from the bottom, and the speed is set so that the biomass will never settle down. Biomass will not come down. That's why it's known as fluidized. So biomass will not come down. The air will keep the biomass suspended at the particle. the bi- the air will keep the particles of biomass suspended in the air. And this mixing is achieved by fluidizing gas and does not require additional mechanical mixing. Fluidized bed reactor is particularly suitable for processing small and irregularly shaped biomass particles such as wood chips, sawdust, due to its efficient mixing and heat transfer process properties. So this high gas flow rate is responsible for very high efficient mixing. Therefore, irregularly shaped biomasses can be used in fluidized bed reactor. And in the ablative reactor, the biomass is fed onto a hot surface that is rotating at a very high speed. In this, there is no air. In fixed bed and fluidized bed, we were using some kind of inert gases or very high flow rate of air or gases. But in ablative reactor, we are using a hot surface which is rotating at a very high speed. The heat generated by the hot surface causes the biomass to undergo pyrolysis, and the vapors produced are collected and condensed. The ablation process helps to break down the biomass quickly and efficiently, but it requires very high energy input and can also reduce the production of char. So we are using very high hot surface, which is rotating at a very high speed. This causes the requirement of high energy in the process. So the main disadvantage of ablative reactor is high requirement of energy, and also it produces high amount of char, which is undesirable because we need either fuel gases, or we need bio oils out of the pyrolysis reaction. But in a rotating cone reactor, the it uses mechanical mixing of biomass and hot sand to facilitate the heat transfer and pyrolysis reaction. So in this, sand is used, which is so the sand will be heated. It will be a heated sand, and this sand will be in contact with the biomass. This type of process leads to very good heat transfer. So the heat transfer done by sand to the biomass is very good, and that's why the process is very it produces a high yield process. So the reactor consists of a conical vessel with a rotating shaft that mixes the biomass with sand. The hot sand acts as a both heat transfer medium and a bed material to support the biomass during the process. And this rotating motion also helps evenly distribute the heat and facilitate the contact between biomass and hot sand, leading to more efficient pyrolysis. The rotating cone reactor has been shown to have high conversion rate and high yield quality of bio-oils. So rotating cone reactor uses a rotation plus sand which is already hot. And this is hot sand is used for high heat transfer rates. That's why it results into high yield of bio oils. Its question is, which of the following is false for DBT ICT2G ethanol technology? So first of all, what is DBT ICT2G? So this is a method which our country India has made, and this is this process. This is a process used to make ethanol. I will explain this process in the next slide. So first of all, the answer for this is that low conversion and slow process are not a disadvantages. These are wrong. Therefore, A and C both are false. DBT ICT2G is a very high conversion process. It has a very high yield, and it also is a very it requires very less time for the reaction. But what is this DBT ICT2G technology? So this technology was developed by a Department of Biotechnology and the Institute of Chemical Technology, and 2G shows the second generation, that it was a second generation type of ethanol which they produces, and this process is known for high conversion rates and efficient recovery of enzyme and chemicals, and it also is a very fast process. This technology was first uh, done in Uttarakhand by and was done inside IGL, Indian Glycol Limited. They used this DBT ICT2G ethanol procedure to produce ethanol. Therefore, A and C are false because it has a very fast process time, and it has a high conversion rates. And the main advantage of DBT ICT is that it can use any type of crop residue. There is no requirement of sizes or variety of crops. It can use any type of crop residue to make ethanol and a very competitive price. So it is a technology which was developed by Department of Biotechnology and Institute of Chemical Technology in India. And this is by far the best technology to produce ethanol from waste biomasses or mixed biomasses. We can also use any mixed biomasses here. And it is a process for the production of ethanol from lignocell biomass such as agriculture waste, forestry residue, and energy crops. In this process, biomass is first pre-treated to remove lignin. We know that biomass is made up of cellulose, hemicellulose, and lignin. So in this first, the lignin is removed. so that the accessibility of cellulose and hemicellulose for enzymes are higher. The pre-treated biomass, when we have removed the lignin, it is known as pre-treated biomass. It is then hydrolyzed using mixtures of enzymes and then convert the cellulose into and hemicellulose into simple sugars. And this resulting sugar solution is then fermented using specialized yeast strain to produce ethanol. So it seems very simple, but the main aim was to recover all the type of chemicals from it also. In this process also uses recovery of chemicals so that the process is very efficient. So this is a block diagram of how this process works. So first of all, we take biomass which has hemicellulose, cellulose and lignin, and we do the size reduction of it for further processing. We do the size reduction and then go for the first pre-treatment. This first pre-treatment requires water, NaOH, and some kinds of acid, and this is done to remove the lignin from the biomass. And after the pre-treatment, it goes for filtration process. In this filtration process, nitric acid is filtered using a membrane, and this nitric acid can again be used for pre-treatment. So there is very less loss of chemicals also, and we are reusing the chemicals. And after filtering the nitric acid, we take the solids and do the second pre-treatment with the water, which is washing. It is a type of washing, just to remove the lignins from it, because we have separated the lignins first pre-treatment. After this, the filtration is done, and it has some NaOH inside it, because we have also used NaOH for the first pre-treatment. This is then filtered and by using membranes, and then these recycled NaOH can again use for pre-treatment of again used for second pre-treatment here. So in this way, we are utilizing our nitric acid and NaOH. Therefore, we are recycling every chemical inside this process. After this pre-treatment, when we second pre-treatment, we get what is known as sugar. So these sugars are then sent for enzyme hydrolysis, and these there are very different combination of enzymes. These variety of we they this process uses very wide variety of enzymes and mixture of enzymes to do the hydrolysis, so that the process is optimized very much. And after this hydrolysis, it goes again for the filtration, so that we can again get the enzyme, and this enzyme is again recycled back for this process. So in this way, we get a glucose component, which is then fermented and then sent for distillation, so that we can get ethanol. But in every process, whichever we are using, we are using water, NaOH, nitric acid, enzyme, or again we are using water. We utilizes all the waste chemicals again. So this is a very optimized process, and it also uses very less amount of chemicals, and it can also take wide variety of lignocellulosic biomasses. So this was a technology developed by India and is now being commercialized in very various forms. So let's move on to the ninth question. Which of the following can be identified as pre-consumer and food consumer waste? So we have seen from the previous questions also that what are pre-consumer and post-consumer. So pre-consumer are some agricultural waste. We can call them as commercial waste, and post-consumer can be waste from cafeterias, which we have already used. That's why it is called post-consumer, and these are pre-consumer. So, in general, pre-consumer food waste refers to a food that is discarded before it reaches to the consumer, such as trimming, scrap from food production, expired or unsold groceries. And on the other hand, post-consumer food waste refers to food that is discarded after it has been purchased and consumed. such as food scrap from household, restaurant, or other food service establishments. And now the last question of assignment 2023. The reactor employed in BTG fast pyrolysis is. So there's a process of BTG fast pyrolysis. What type of uh, reactor is used? So in this process, rotating cone reactor is used, and BTG's fast pyrolysis process is based on the rotating cone reactor, and in this BTG fast pyrolysis method, the reactor was originally developed by University of Twente, in which is in Netherlands, and BTG has since acquired the technology has improved it. So this reactor was developed by University of Twente, Netherlands, but then further BTG has acquired this technology and then improved this also. So it is a type of rotating cone reactor. So we have seen also seen where what is a rotating cone reactor. It is nothing but a reactor which rotation occurs in the presence of heated sand. So this heated sand is in contact with the biomass to transfer heat to the biomass in a very high efficient manner. So this reactor design allows for efficient mixing of biomass and hot sand, which enhances the heat transfer and improves product yield. So that's all for today, and I hope that you have understood the concepts of assignment 5 of 2023, and we'll meet you all in the next week when I will be discussing about the assignment 6 and assignment 7. So thank you for listening, and we'll meet you next week.